Calculate the molar mass of the following compounds. There are 3 compounds they're going to ask us to calculate the molar mass for. Asking us be sure we have proper units, which is always the case. Grams per mole will be the proper units here for molar mass. So that means we're going to make an assumption here that we have 1 mole of each of these compounds. Therefore, we have the designated number of atoms of each element in 1 mole of the compound. Let's start and do this in order. We're going to start first with iron 3 chloride, FeCl3. We have 2 elements in this compound, iron and chlorine. So we're going to need to first determine the number of atoms of each element in the compound, or number of moles, I should say. So I have 1 mole of iron and 1 mole of iron chloride, as indicated by the subscript 1. So I'm going to write 1 mole. And I'm going to multiply that by its molar mass, which we get from the periodic table. So finding iron on the periodic table, element number 26, 55.85 is its molar mass. So let's multiply it by 55.85 grams per mole. And that's going to give us grams in 1 mole. And that's, of course, going to be 55.85 grams. For chlorine, we have a subscript 3, which means we have 3 moles of chlorine in every 1 mole of iron chloride. We need to find its atomic weight, chlorine number 17 on the periodic table, 35.45. So we write down here 35.45 grams per mole. Moles cancel, we're going to be left with grams. We get a value of 106.35 grams. Now, our significant figures here, we've got 4 significant figures in our molar mass. The number of moles of each element in the compound, that's an exact number. So we need to round our answer here to 4 significant figures. So I'm going to erase that 5. I'm going to erase the 3 as well and turn the 3 into a 4 since we want to round that up. So the 4 significant figures, our molar mass contribution from chlorine is 106.4. So now we have a different precision in the 2 elements. So we're going to again draw our vertical line and we're going to discard everything to the right of that, rounding up if necessary, and we will because a 5 is going to round up. So let's add what we have here, and we have 161.25 grams, and rounding that up gives us a molar mass of 161.3. And now the units are grams per mole. Where did that per mole come from? Remember, we says that we are assuming we have 1 mole of the compound. So in 1 mole of iron chloride, we have 161.3 grams. So we just write it as 161.3 grams per mole. So let's now move on to part B. Part B asks us to calculate the molar mass of nitrogen triiodide. So let's write that. Ni3 is the formula. Procedure exactly the same as it was with iron chloride. Write the elements nitrogen and iodine. Again, we're going to assume we have 1 mole of nitrogen triiodide, which means we have 1 mole of nitrogen atoms in 1 mole of the molecule. We need the molar mass for nitrogen. Going to the periodic table, we find nitrogen right here, element number 7, 14.01. So let's write that in. 14.01 grams per mole. Moles cancel. So we're left with 14.01 grams of nitrogen in 1 mole of nitrogen triiodide. For iodine, our subscript 3 tells us we have 3 moles. So we'll write that. Now going to the periodic table, we got to find iodine, element number 53. 126.9 is the molar mass. So let's write 126.9 grams per mole. And now we're going to multiply that together, and we're going to get 380.7 grams. Again, we need 4 significant figures in our answer. We have 4 significant figures in our molar mass of iodine, so we round it to 0.7. Again, we're going to add these two, and again we see that we have different precision in our two measurements here, so we're going to drop everything to the right of our vertical line. But let's add these two together and see what we get. And we end up with 394.71 grams. We're going to drop the 1, X that out. It's less than 5, so we do not round up. So our molar mass for nitrogen triiodide is going to be 394.7 grams, again in 1 mole. So we'll write it on a per mole basis. Moving on now to our third and last compound in this problem. Ammonium sulfate, they want us to calculate the molar mass of that. So let's rewrite the formula here first. NH4, and that's taken twice, so we have the parentheses followed by the polyatomic anion sulfate. A little bit more complicated than the other two simply because there are more elements. We also have a bunch of subscripts here, and we have parentheses and subscripts around the parentheses. So how do we sort this out? First thing, again, we want to list all of the elements in the compound. There are 4 of them: nitrogen, hydrogen, sulfur, and oxygen. So let's just write them in order. It doesn't matter, just as long as everything is accounted for. So there they are. Now we have to count the number of atoms of each element in the compound just as we did before. Starting with nitrogen, we have 1 nitrogen in the ammonium polyatomic cation, but the parentheses with the subscript 2 tells us that we got to multiply everything within the parentheses by the subscript right after it. So we're going to multiply the 1 atom of nitrogen in the ammonium ion times 2. So that means we have in 1 mole of the compound 2 moles of nitrogen. And we're going to look up the molar mass of nitrogen on the periodic table. We find nitrogen, element number 7, 14.01. So we're going to write that, 14.01 grams per mole. And now moles are going to cancel, and we're going to end up with 28.02 grams of nitrogen in 1 mole of ammonium sulfate. Now we go to this next element, hydrogen. We have 4 hydrogen atoms in the polyatomic cation, but the subscript 2 again outside tells us we multiply that by 2, which means we have a total of 8 moles of hydrogen. Now we go to the periodic table. We find the molar mass of hydrogen. Element number 1, molar mass is 1.008. So let's write that in here, 1.008 grams per mole. And now moles again cancel. We're going to multiply that, and we're going to end up with 8.064 grams. 4 significant figures in both of these numbers. So let's move on now to sulfur. Sulfur is, there's only 1. There's no parentheses around it. The 4 does not apply to sulfur. We have an implied 1 here after the sulfur. So we have 1 mole of sulfur in 1 mole of the compound. Going to the periodic table. Sulfur, element number 16, 32.07 is its molar mass. So we write in 32.07 grams per mole. Moles cancel. Multiplying that out, very easy to do, 32.07 grams. Lastly, we have oxygen. There are 4 oxygen atoms in the compound. We have 4 moles of oxygen then in 1 mole of the compound. So we multiply our 4 moles times its molar mass. Periodic table gives us oxygen, element number 8, with a molar mass of 16.00. So let's write that in, 16.00 grams per mole. And now multiplying that, we get 64.00, again, 4 significant figures. Once again, we do have 1 element here, hydrogen, with a different precision. Everything has 2 decimal places except for the hydrogen. So what we're going to do now is add things up and get our molar mass. 132.15 4 grams in 1 mole. As we've already discussed several times now, we're going to discard everything to the right. And since 4 is less than 5, we're just going to drop it. And we now have our molar mass of ammonium sulfate. And let's rewrite it. 132.15 grams per mole.